Hello, welcome back to this video series, I mean. Last time we talked about form dictionary. So now I want to bind all this learning together into this video so that we can start at least try we want to at least try to modify the cavity file using form dictionary and of course a few of those bash functions that we learned so that we can automate some processes. So let's have an example case. So I'm going to take GIMP and try and explain to you what we're going to do. All right. For the cavity case, if you don't already know, the cavity case is like that. You have 3 walls of no slip. Okay. No slip. Okay. No slip. No slip. And of course, you have some velocity here, u going at 1 meter a second. I can't remember actually what the speed is, so I'll just put a question mark here. Now, okay, so the cavity is basically this case, u will be going at 1 meters a second, then the flow inside this square or something like that, or this cavity is going around in this circle. Now, let's say I'm gonna clear everything. Let's say I want to do something a bit more special. So I want my cavity to be like that. So for the first 10 seconds, so this is 0 to 10 seconds. I want this going at 1 meter per second. Then in the next 10 seconds, I want my script to be able to change my boundary conditions and patches such that from 10 to 20 seconds, this bottom lid will go at 1 meter a second or whatever speed I'm specifying. And of course, now the top will become a no slip. Okay, a no slip. No slip BC. Oopsie. Yeah, no slip boundary condition. Okay, so the no slip BC will now be on top, and then at the bottom it will be a 1 meter a second. Okay, so this is the idea of what we want to do. So for the first 10 seconds, I want it to play. I want the case to play like a normal cavity file, and then in the next 10 seconds, I want the top to suddenly stop moving and the bottom, what do you call that? The plate or the side with the least x value, or just opposite of the top. Okay, maybe this is the top side. This is the top side. Maybe you call this the top side. Okay. This will be moving. Will not be moving anymore, and this bottom side will now start to move. Okay, so that's the aim of what we are trying to do here. And we're trying to use some bash scripts to get everything done. Now first, we've been making lots of nonsensical edits to this example file. So if we try to run block mesh, we will run into errors because you will see this form fatal error, input output error, IO is input output, rubbish is not in enumeration, blah blah blah. So I need to sort of reset this file. Okay, so form dictionary, okay, system control dict. You will see that you will see the stop at is now rubbish, which is an invalid entry. So let's look for the entry stop at. Okay, and then let's set the value to end time. Okay, so let's see. Let's do form dictionary system control dict. Now we see that our end time now is at 0.5. Our start time is 2. Okay, we don't want the start time to be 2. We want to start from the latest time. So let's change the start from to latest time. So I'm going to do all this manually first. Okay, form dictionary system control dict. What what are we doing? We do the entry start from set latest time. Okay, so we want the thing to start from latest time, and the start time will be 0. Okay, just to make things consistent, the start time set 0. The start time is set at 0, end time is set at 0.5. Now we want to change that, right? So we want to change the end time, at least for the first 10 seconds. We want to set it to 10. So let's see the foam dictionary, see whether it works now. Okay, system control dict. Okay, so this is how it should be. Let's run block mesh. Okay, and now we run OpenFOAM. It will run very quickly as usual. We should expect it. So yeah, within a few seconds, yeah, it's finished. Okay. Of course, we see the Cora number now is like 1.7. Okay, so that's a bit too fast. And then now we have all of these things here. So how do we clean it? Well, we can use foam clean tutorials. This script to actually clean the file up very nicely. Okay, so this is roughly how we want to play with our system. So we run block mesh and OpenFOAM and it works. Now this actually works fine for the first 10 seconds, but of course you want to change some boundary conditions. So let's see. CD0. Okay, I can do cat star to actually cat both of these files. You can see the value here is uniform 200. I want it to be uniform 100. Okay, so foam dictionary. I'm going to again try to get you used to using foam dictionary. So I'll be using lots of examples here. Okay, so what file do I want to manipulate? I want to manipulate you, and I want to look for the entry. Okay, what entry do I want to look for? Boundary field dot moving ball dot value. Okay, I want to change this value. So to probe what the value is, I just type foam dictionary, the file I want to edit, which is the velocity file, u entry boundary field moving wall value. Okay, so yeah, let's change it to uniform 100. Okay, and that should about do it. And that's it. Okay. So yeah, well this is our initial condition. So actually for the first 10 seconds this is fine. This actually achieves our goal. This setup achieves our goal for the first 10 seconds. I want the cavity case, the top wall, to be moving right at 1 meters per second for the first 10 seconds. But now for the and then after running from 0 to 10 seconds, I need to edit some boundary conditions and files at the 10th second, and then we kind of do some changes from there. Let's see the time. Okay, so we are about halfway through. I want to make this video about 20 minutes, not too long. So yeah, the challenging part now is to make sure the bottom as well has a different is able to move to the right at 1 meter per second, or to the positive x direction. Now let's see. Let me close this. Let's see how this can be done. So if we look at foam dictionary system block mesh dict, okay, we see that there are several phases in this thing called fixed wall. Okay, so now I actually want one of these faces to start moving. Okay, I want one of these faces to start moving. Okay, and not only that, so that means let's do. This is a bit hard to see. Let's do cat system block mesh dict. Yeah, this is what I want. Okay, so remember, all three of these faces, they are going to be considered one patch. which is problematic because I cannot change the boundary condition of this patch anymore. I need to start to I can't change the boundary condition of these faces one at a time, like this face 0473, 2651, and 1540. I can't change these patches one at a time anymore. All right. I need so first I need to isolate the patch that I want to the face that I want to define as a new patch. Okay. So remember, so what we are doing? Okay, so I just want to explain again. Okay, never mind. Okay, I assume you know. Yeah, I assume you're already familiar with block mesh. Okay, so I'm looking for this patch now. This or this face. I'm looking for this face now, and this is supposed to be the top face. This is supposed to be the bottom face. So I'll probably do some renaming over here. Okay, so let's take a look. Yeah, this is the top face. I will not call it moving wall anymore. Okay, I will call it the top. Okay, and these fixed walls will still be fixed, but I want to isolate the patch or the face that is directly opposite here. So how do I know which face is directly opposite? Well, if you're familiar already with block mesh, which I assume you are, 3672 will be the 4 vertices of the top patch. So for any patch just adjacent to this surface, I should expect one or more of these numbers to appear in each of these faces here. So if for example, I see the number 2, okay, number 2 appears in this face over here. Okay, number 3 appears in this top face over here. So these two faces, you can kind of tell they are directly adjacent. This face, however, 1540, this face does not share any numbers with this top face. So what I will do, I want to pick it out of this. All right, I want to take it out. Of course, we can do it manually, but we can also use Foam Dictionary to help us a lot. Okay, so so this is the original case. So this is so-called the original case. All right. So let's see. Let me check the system again. What? Let's go to system. Yeah. Yeah, this is the original case. All right. But let's say we want to use Foam Dictionary and we want to implement all the bash scripting that we've learned in the last few videos. How are we going to do it? All right. So instead of using this example file directory as my case directory, what I want to do is to copy this example file into another file using a bash script, and then we start editing from there. Okay, so basically I'm copying this example file into a new file, and then let's go to new file, and I can run my case over here as and how I like. So that's the idea. So let's remove the new file. Let's remove the new file, and let's start having ourselves a new bash script. We'll call this all run. Now it's pretty descriptive. All run is a standard name for the script. Let's see, and we'll probably want to take an all run file. We want to take a minute. Yeah, we can actually copy this all run script from here, and then we'll just edit. Okay, so vim all run. Okay, so most of this I will just delete. Okay, I will just delete because I won't be using a lot of these case structures, a lot of these set commands here. I will actually do something new. Okay, so yeah, you'll just do that. The only thing I want to really do is to take all of these things on top. For example, the hashtag bin sh or bin bash. then this cd something something exit, and you can see I'm just deleting everything at the bottom. Okay, maybe I should just, yeah, maybe I should not have deleted it. Okay, but maybe 500u, 50u, 6u, okay, 7u. I'll undo all of that. 7u, 7u. Okay, let me write this first. Okay, now maybe I won't delete all of this. These are nice functions which I probably won't even use. But what I will just delete is this one here. Okay, because I don't want to actually execute any of the code over there. Or maybe, let's see, let me think. 10, 100, 100u. U. Oopsie. Never mind. Let me quit and I will. Let me remove this all run file. Let me copy again. Cavity all run. I'll put it here. Okay, so I'm going to edit this all run file again. Okay, so pardon me just now. Okay, the last one is, okay, I will just this batch of code here, I do not want to execute it at all, but it's a nice template for me. So what I do is I will just make it into a function. I'll call this run cavity case, and then I will save everything here into a function which I will not call at all. Okay, that effectively almost makes it into a comment. Yeah. So this is just run cavity case. So if I actually type in all run here, nothing will happen because it just defines a few functions which are never called. Okay, which are never run at all. So all of these are just here for reference. So I won't delete any of this. Okay. Okay, so I'll leave that here in case we need some random inspiration to, like, look back and see, oh, how can we copy bits of code to for our bits of code. All right, so let's first see how we can do a clone case. Okay, foam clone case, because that actually okay, how can we automate the copying process and editing process? So first thing first, we want to copy. So let's copy using CPAR. We can use that CPAR example file, and we call it new file, right? Okay, so there are two ways of doing it. We use CPAR directly, or we can use the foam clone case command. So let's try with the normal what we are used to first. So I'm going to define a function here. Okay, I'm not going to save a screenshot. Let's define a function. I'm almost running out of time. My bad. Yeah, let's define a function first called copy case. Okay, copy case. And what will this do? Okay, I'll need to include two brackets here, and I will need to do two things. Okay, copy case. So what is this? CPAR. I want to copy the first case into the second case. So what do I do? Copy case. This is really redundant, but I'm just demonstrating how to get things running. So I'll do example file, and I'll put it into what do you call it? I'll just call this cavitySwirl, because this thing looks like it's swirling in a back and forth motion. At first, your cavity is going like this, and then after that, because the bottom lid is now moving to the right, it will switch it in the other direction. I just call it a cavitySwirl case. Okay, very unimaginative, but yeah, let's see whether this works. So if we do all run, we should have something called cavitySwirl. Now that's one way of doing this, okay? But for the sake of learning, I want to do something called foam clone case. Oops. Well, I just removed my cavity file by accident. So that probably signals the need for me to actually have all clean, okay? So CP, let's copy the cavity case again. Incompressible icofoam. Yeah. Cavity. Oh. Yay. My goodness. What's going on? Hold on, let me copy the cavity file back here again. Okay, here's one easy way to restore cavity. We can use this command since we already in a git folder. We can just use git restore cavity. Okay, if you look at git status, you see that all my cavity files are now deleted. We can just use this command called git restore. Okay, git restore cavity if you delete it by accident. So now the cavity is back in action. So let's copy the cavity all clean file. I want to copy it here. And let's go to all clean. Oops, right. Name all clean. So this I call this cavity clean. Okay, and I'll do it here. Again, this will do nothing, but now I just want to remove, or rather I can use foam clean tutorials. Oh, no. You can see we use the function rim. Okay, maybe I'm going too fast. Let's just use rm-rf. What are we cleaning? Okay, we'll call it cavitySwirl. I want to remove cavitySwirl. Okay, so let's remove cavitySwirl. Okay, so that's it. I'm gonna run all clean. And now cavitySwirl is gone. Okay. Now, I want to show you something. There's a special command that helps us to copy files over. It's called foam clone case. Okay. How do you use foam clone case? Okay, you look at the help. Okay, it says create a new target case directory that includes time, which is probably 0, system, and constant. Okay, you can specify which time you want to copy over. So you can just use this -L to indicate that I want to copy only the latest time directory. So you save yourself some space. Okay, so to give you an example, instead of using CPAR, which is what you should be quite familiar with, we can use instead foam clone case. Okay, I'll use the latest time flag, and I'll put $1, $2. Okay, so if I do all run, I should be able to do the exact same thing. I want to make a cavitySwirl case. So you see, making cavitySwirl case directory, copying case directory from example file to cavitySwirl. So it gives you some comments as to what's happening. So we look at this, we can do ls cavitySwirl. You can see the 0, constant, and system are all there. Now these are ready for you to edit. Now, why do you want to do things like that? Okay, because if example file is a case you can run, and you don't want to touch anything there, what you normally want to do is to make copies of it and then edit it. Okay, so that you don't break your original example file or original case. All right. So you only perform edits on the case that you actually want to run over here called cavitySwirl. Okay, so that's the idea behind some of these all run files. For example, what you see in cavity. If you look at this cavity all run, it will copy some of the cases from over here. Yeah, it will copy some of the cases from over here. Yeah, cavity find and cavity high Reynolds number will be copied from another case directory. Okay, some of them are already there, but some of them you copy over and then you start to edit. And this is what we want to do with our bash script. So you want to copy this example file over into cavitySwirl and then we edit this file. Okay, I think I'm already run over time. So yeah, I think we'll stop for now. And I'll continue more, elaborate a little bit more in the next video. How to actually start using the all run script to start editing this cavitySwirl file. Okay, thanks for watching. I'll see you again. Bye-bye.